16b, same thing. This time it's maybe not as easy to use the intercepts to get this function's equation, the equation of this graph. It looks like 4.5 and negative 1/2, but I want to be certain. So to be certain, I'm going to use this. That is my vertex. So I know my vertex form equation will be y equals some a value, my stretch factor, times x minus 2, because it is centered at the x value of 2, squared minus 3, because the y value of the vertex is negative 3 right there. So normally, to find that a value, you go from the vertex and you say, if I go over 1, how far up have I gone? And again, it looks like we've gone up 1/2, so it looks like our stretch factor a should be 1/2, but I want us to be certain. So in order to be certain, let's choose a point to plug in. This is a good point to plug in because the x value is 0. So let's plug in the y value of negative 1 equals a times the x value of 0 leaves me with just negative 2 squared minus 3. So we'll add 3 to both sides. Negative 1 plus 3 is 2 equals a times negative 2 squared. Well, negative 2 squared is 4, so that's 4a. So divide by 4. 2 divided by 4 is 1/2 equals a. So my stretch factor was 1/2, but it's good that we verified. It's always good to verify. So 1/2 x minus 2 squared minus 3. That is my vertex form equation. Why don't we go ahead and find the standard form equation by expanding everything? So if I expand everything, then we'll have 1/2 times x squared minus 4x plus 4 in parentheses with a minus 3, right? I expanded that binomial x minus 2 quantity squared. You should be comfortable with that. And now I am going to multiply that 1/2 in. So I will get 1/2 x squared minus 4 times 1/2 is 4 divided by 2. 4 over 2 is 2x plus, again, 4 times 1/2 is 2. And then I still have my minus 3. So my final standard form equation would be y equals 1/2 x squared minus 2x plus 2 minus 3 is minus 1. And I know it's minus 1 because that represents my y-intercept right there. Okay, so there's vertex form, there's standard form. Now all we need is factored form. And again, like I was saying, it looks like it's going to be x minus 4.5 times x plus 1/2. Weird that I did a decimal and a fraction, I know. But it looks like that's where those x-intercepts are. And we can verify it, make sure this gives us a correct point. So let's just plug in 0. If we plug in 0, we should get negative 1. And do we? So 1/2 times 0 minus 4.5 is 4.5, which I'm going to write as 9 over 2 is 4.5, but it's negative. So that times 0 plus 1/2 is 1/2 right there. So let's multiply all our numerators. Well, we just are left with a negative 9 in the numerator. In the denominator, we have 2 times 2 times 2. And so if you notice what's happening, we're getting negative 9 on the top, we're getting positive 8 in the bottom. So we're getting negative 9/8, which is not equivalent to negative 1. So that's telling me that that is actually not the same equation, which means although it really looks like those x-intercepts are at 4.5 and negative 1/2, they're not. And so we can't factor it like that, which is like kind of cray. But we could find the solutions using the quadratic formula. I don't know that I really want to. I don't know that you really want to, but we could. Okay, so I went ahead and did it. If you do quadratic formula on the equations we've written, we get x equals 2 plus or minus the square root of 6. And if you like approximate that, you get roughly 4.449, which is really close to 4.5, but isn't, and roughly negative 0.449, which is also really close to negative one half, but isn't. So that's interesting.